Hello, chemistry students. These are the corrections for page 418, questions 1 through 6. Question number 1. How can the periodic table be used to infer the number of valence electrons in an atom? So this is asking you, how can you use the periodic table to figure out the number of electrons, valence electrons, which are those highest occupied energy level. And remember for that, that's what these A's are about. Remember the number in front of the A is telling you how many electrons there are in the valence shell of the electrons. So that number, so in group 1A, we have 1 valence electron. In group 2A, 2 valence electrons. Okay, in group 7A, there's 7 valence electrons, and so forth. So the group number equals the number of valence electrons for the representative elements, which are the tall columns of the periodic table. Number 2, why do metals tend to form cations and nonmetals tend to form anions? Again, that kind of goes back to the periodic table again, and the idea that the metals over here, right, tend to form cations because, again, they only have 1 and 2 electrons in their valence shell. And remember, everybody's trying to be like the noble gases and have 8 electrons in their valence shell. So, because their valence shell is relatively empty, it's easier for the metals to lose their valence electrons to get the electron configuration of the noble gas 1 row above them than it is to gain electrons. Again, your textbook said it is easier for a metal to lose electrons and for a nonmetal to gain electrons to achieve the electron configurations of a noble gas. So for these nonmetals, again, it's because these have 5, 6, and 7 valence electrons, and it's easier for them to gain 3, 2, or 1 electrons to have 8 rather than to lose them. Number 3, how many valence electrons does each atom have? Letter A, potassium. So again, to answer this, we look at our periodic table. So letter A is potassium, which is right here. And so it's in group 1A, so it has 1 valence electron. Letter B is carbon, which is right here. It's in group 4A, so it has 4 valence electrons. Magnesium is right here. It's in group 2A, so it has 2 valence electrons. And oxygen is in group 6A, so it has 6 valence electrons. Number 4, write the electron dot structure for each atom in question 3. So remember, in our electron dot structure, we just show the valence electrons. So potassium would be symbol K with just 1 dot. Carbon, remember, had 4, so it's a C with 4 dots, and we put the dots, remember, on separate sides before we start to double them up. Magnesium had 2 valence electrons, so it would have 2 dots. And oxygen had 6 valence electrons, so 1, 2, 3, 4, 5, 6 valence electrons. So those are the electron dot structures for those. Number 5, write electron configurations for the 1+ ion of copper and the 2+ of cadmium. So to look at that, we're going to look at copper first. We want to just look at plain old copper's electron configuration. So again, we're going to write out the complete electron configuration for copper. So that's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and copper is 9, so 3d9. So the issue is when copper loses one electron, it is actually better for copper to lose one electron from here, and then this electron that's left kind of jumps up here, and that happens because these two orbitals are so similar in energy, so that this 3D ends up full. So the electron configuration for copper with a +1 charge where it's lost one electron is 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d10. So when we talk about cadmium, we'll kind of look at the same thing. We'll look at cadmium as an atom without having lost its electrons. So 3p6 takes us to argon. We're going to cadmium, so we're going to go 4s2, 3d10, 4p6. That takes us to krypton. And then 5s2, 4d, and cadmium is 10. So now we want cadmium to lose 2 electrons. And again, what happens here is rather than having this D end up with a D8, those 2 electrons come from here. And so your cadmium with a 2+ charge electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and 4d10. Because again, it's more stable for this D to be completely full than for the S to be completely full and the D to be incompletely or not completely full. And again, this is also going to happen not just for copper, but for every other element in the same column as copper. So silver and gold would do that. And for cadmium, zinc and mercury would also do this because they're in the same family as cadmium and copper. Question number 6. How many electrons will each element gain or lose in gaining an ion? And again, that has to do with being like a noble gas. So again, we find calcium, and calcium's right here. So notice it has 2 valence electrons, so calcium's choices would be it could lose 2 electrons to be like argon, or it could gain 6 electrons to be like krypton. And again, it's always going to do what's easier, so it's going to lose 2 electrons, so it's going to, calcium is going to lose 2 electrons. So letter B, fluorine. So here's fluorine. And again, its choices are it could lose 7 to be like helium or gain 1 to be like neon. And again, it's going to be easier for it to gain 1, so it's going to gain 1 electron. So aluminum is right here. So it has 3 valence electrons. It could lose 3 valence electrons to be like neon, or it could gain 5 to be like argon. And again, it's going to do whatever's smaller, so it's going to lose 3 electrons to be like neon. And lastly, we have oxygen. So here's oxygen. It has 6 valence electrons, so it could lose its 6 to be like helium, or it could gain 2 to be like neon. And again, it's going to gain 2, so it's going to be like neon. So I hope if you had some questions about that homework assignment, that helps. Have a great day, and I'll talk to you later.